Hi, welcome to this lesson on analytical geometry, circles part 2. Let's have a look at equations of circles with a non-center origin. So just as we use the Pythagorean theorem to derive the equation of a circle with the center being the origin, we can use the distance formula between the 2 points in a similar fashion to derive the equation of a circle where the center is given by an arbitrary point now hk, which is not the origin 0, 0. So if we consider an arbitrary point C, hk, in the Cartesian plane and plot the points that are equidistant from C, and we call that distance r, then this distance will be the radius of the circle and the center will be the point C, hk. And we will have the following equation. So we'll have x minus h all squared plus y minus k all squared equals r squared. So this is the general equation of a circle with a center of hk and a radius of r. If we note that if we put the point C to be 0, 0 for the origin, then if I put h to be 0, I get x minus 0 all squared. And if I put y to be 0, I get y minus 0 all squared. Now x minus 0 is just x squared, and y minus 0 is just y squared. So if we substitute back the origin, we see we get back the traditional equation of a circle with center origin. Okay, so here I've chosen an arbitrary point C and I've called it hk. And what I've done now is I've chosen a point P somewhere that is a distance r units away from C inside the Cartesian plane. Okay, then if I'm going to look at the collection of all points, another point R, another point S, another point T, if all of these are the same distance R away, then the collection of all those points is going to form a circle. And I'm going to claim that the circle's equation is going to be this equation here. So how do I do that? Okay, well, first things first, what we're going to do is construct another point in the plane, and we're going to call it Q. And Q is going to be this point where it's still going to have, so it's going to move parallel to the x-axis, and this one's going to move parallel to the y-axis. So it's going to meet perpendicularly here. So if I drop from P perpendicularly down to this point, they're going to have the same x-coordinate, x. Okay, but the y-coordinate's going to be different. And in fact, the y-coordinate's going to match up to the y-coordinates here on the center, which is k. So we get xk as this point Q. Okay, this is a right angle triangle. In this right angle triangle, the hypotenuse, CP, is r units. Okay? And then, how do I find the distance of CQ? And how do I find the distance of PQ? Now over here, I've used the distance formula. But we don't have to use the distance formula necessarily. Okay, the reason for that is that if you look, C and Q are on the same horizontal plane, right? So their y values are the same. So the distance is just the difference in the x values, x minus h. Notice I put these two bars here. This means the absolute value of those. The absolute value is just the mathematical notation to ensure that the distance is always positive. So that's what that symbol means there. It's the positive distance of x minus h. Because again, this is a distance of a triangle, so it makes sense for it to be a positive value. And the same thing is true here, right? The x values are the same, so it's on the same vertical plane for P and Q. So the distance between their y values, y minus k, that absolute value there is the length of that side. But if you're going to use the distance formula, remember the distance formula tells you that is the square root of the x1 minus x2 squared plus y1 minus y2 squared. And that's what I've done here if I use the distance formula. So the x1 here, so let me just neaten this up so we can see it again. So again here, the x1, so for CQ, I'm calling this one let's call that x2, and then this one's x1. So this one will be y1 and that'll be y2. So if I do x1 minus x2 all squared, that's x minus h all squared. Plus, then if I do the y values, y1 minus y2, it's k minus k. K minus k is just 0. So that's why that term vanishes. So you just have the square root of x minus h all squared. So the square and the square root will cancel, and you're left with the distance of that. And the same ideology goes for here, for this length PQ, if you use the distance formula. So you don't have to necessarily use the distance formula, but that is just the algebraic setting if you wanted to use it. I used also the geometric reasoning, which just finds the distance by looking at the lines here. Okay. So if I use the Pythagorean theorem on this triangle PCQ, then it means that this distance CQ squared, which we know is x minus h, so x minus h squared, plus the distance of PQ, which we worked out to be y minus k, so y minus k all squared, equals the hypotenuse r squared. But what we've done is we've derived the formula of the equation of a circle with non-center origin. All right. So let's have a look at an example. If we have the circle with center 2, negative 3, and radius r equals 5, then the equation of the circle is given by, so it's always x minus and y minus these values here. So x minus 2 and y minus minus 3. So just be careful algebraically about your signs. So inside the brackets, it becomes x minus 2 all squared, and inside these brackets, it becomes y plus 3 all squared. And then 5 squared is 25. So this is the equation of that circle with center 2, negative 3 and radius 5. Now, which of the following points is on the circle? P, Q, and R. So P is 6, 0, Q is 0, 5, and R is negative 2, 0. So to test points are on a circle, we need to substitute the x and y values into the equation of the circle. And if it gives us the radius squared length, then it's on the circle. If it doesn't, then it's not on the circle. Okay. So if I put in the values 6 and 0 for x and y, I'll have 4 squared plus 3 squared, which is 25, and that is a point on the circle because we get 25. Okay, so P is a point on the circle. If I put Q, so if I put x is 0 and y is 5, I'm going to get negative 2 all squared plus 8 all squared. But negative 2 all squared is positive 4, and 8 squared is 64. And that gives you 68, which is not the same as 25. So therefore, this point is not a point on the circle. And if I look at negative 2, 0, if I substitute x as negative 2 and y 0, I'm going to get negative 4 all squared plus positive 3 all squared, and that'll give you 25. So again, you can conclude that this point, so Q is not on the circle and R is not on the circle. Okay, so now consider this example with that center 2, negative 3, right, and the radius r equals 5. So it's that equation here. So they're asking us to sketch the circle. So the circle has that center point, and we already worked out 2 points we were given here, 6, 0 and negative 2, 0. In fact, those are the x-intercepts of the circle. Right, notice that there are 2 x-intercepts for this circle, and we can also find 2 y-intercepts for that circle if we substitute x equals 0. So if we did that, if you substitute x equals 0 here, you're going to get 0 minus 2 all squared, plus y plus 3 all squared equals 25. Negative 2 all squared is positive 4, plus y plus 3 all squared equals 25. If I subtract 4 on both sides, I get y plus 3 all squared equals 21. So if I take the square root on both sides, now it's going to be plus or minus the square root of 21. And then to get rid of this plus 3, I will subtract 3. So you get 2 values. Y equals negative 3 plus root 21, or y equals negative root 3 minus minus root 21. Those are the 2 solutions. And again, those 2 values make sense because here's the positive y value one, 0 and negative root 3 plus root 21. And this one here would be when x is 0, y is negative 3 minus root 21. Okay. Now let's have a look at this example. Determine the center and the length of the radius if we're given the equation of a circle. So here's another important thing we need to be able to do. So if you're given the equation of the circle, but it's not in the full form that we wanted, this standard form here, then we need to get it into that standard form. So how do we get it there? Well, we're going to use an algebraic technique that you might be familiar with, that you might have not seen for a while, the completing the square technique. Okay, so we will write this following equation here, okay, by bringing the negative y squared and the positive 4 across. So you're going to get x squared plus y squared minus 4y equals 21. So we need to complete the square for the y terms. The reason why I say that is because the x terms only have x squared, so it's already in a squared form. So we need to complete the square for this expression here, y squared minus 4y. Your first instinct will be, well, why can't I just take out a common factor of y and it'll be y minus 4 and I'll call it a day? Well, no. Remember, you need to get it into this form. And in this form here, it's y minus a number all squared. That is not the same here. Okay, so let's complete the square as follows. Step 1, ensure that the coefficient of the square term is 1. If it's not 1, then you need to take out that coefficient as a common factor and divide it out. Okay, or divide it out. So for y squared minus 4y, the coefficient of y squared is 1. So we're fine. Next, you want to half the coefficient of the y term. So in this case, it's negative 4, and then square it. Then you want to add and subtract that new term so that it preserves the original expression. So what do we mean by that? So y squared minus 4y. This is the same thing as saying y squared minus 4y plus and minus this common term. And again, how do you get that common term? You look at the coefficient in front of y, which is negative 4, and then you divide it by 2. So negative 4 divided by 2, and then you square that term. Okay, and then you add and subtract it, so it balances out the equation, so it's still true. But now we can simplify this. Negative 4 over 2 is just negative 2, and negative 2 squared is 4. So we end up with y squared minus 4y plus 4 and minus 4, because that still preserves this equation here. So now that you've done that, the first 3 terms that you always generate from completing the square will make your perfect square trinomial. So this 3 terms here gets factorized into y minus 2 all squared. And again, how do I know it is minus 2? Again, that's from halving this coefficient here. So it's always y minus half the coefficient. So y minus 2 all squared minus 4. And if you expand this out, you'll see you get the right answer. Y squared minus 4y plus 4. And then there's a minus 4 here. So those will cancel, and you're left with the left-hand side. Okay, so this is the correct completed square form. So we can substitute that expression back into the original equation. So remember, we had x squared plus this term in red here, y squared minus 4y. But y squared minus 4y we can replace with y minus 2 squared minus 4. So that's what we've done here. Now we can just add 4 to both sides, and I get x squared plus y minus 2 squared equals 21 plus 4, which is 25. Okay, notice that x squared you can write as x minus 0 squared. X minus 0 all squared. So we have the general form here. There's your x minus a number all squared plus y minus a number all squared equals radius squared. And in this case, 25 is 5 squared. So the center of the circle is given by the opposite sign of the numbers here. So minus 0, what's opposite of minus 0? Well, if you want to say plus 0, you can, but at the end of the day, it's still 0. And then what is the opposite of negative 2? It is positive 2. Okay, and that'll be the center. Center is 0, 2, and the radius is 5 units. So again, how do I work out the values here if I want them? Well, I look at each square term, and I set it equal to 0. So if I do that, x minus 0 is just x, and that's equal to 0. And then I add 2 on both sides here, and I get y equals 2. So that's how I get 0, 2 here. Okay, by setting each squared term in the brackets equal to 0. Okay, so that is dealing with equations where the circles have a non-center origin. So we use the general form x minus h all squared plus y minus k all squared equals r squared, where the center is hk. Okay, some texts might say AB is the center, so you get x minus a all squared plus y minus b all squared. That's still fine, it's just a notation thing. Alright, so that is how we would do these types of questions. Let's go ahead and look at some more examples. I'll see you in the next one.